So thanks for coming, guys. So my session today is going to be about smart contracts on Ethereum and how to do that very easily within a couple of minutes. I built a so-called Truffle Box, and for the UI, for the decentralized application, I'm doing that for Oracle Jet. So first introduction, my name is Robert van Mölken. I'm a blockchain and integration specialist from Amis, that's a company in the Netherlands. And I'm a developer champion and Oracle Ace. And they changed that to the Oracle Groundbreaker Ambassador. So from now on, I'm calling myself that. I wrote 2 books, one about an Oracle product integration cloud and a book about blockchain. And that's looking at some multiple things, but let's start with, so I'm Oracle Groundbreaker, and I'm that because of IoT and blockchain, but there are multiple, we are the experts in modern development, as we say that. So a little bit about the book. So I wrote a book now in the last 1.5 years about blockchain across Oracle. And what I discussing there is really the executive summaries about the book, but also I'm gonna talk about terminology, technology, implementation. I'm looking. I compare Ethereum with Hyperledger, and then I'm using the Oracle Blockchain Cloud Service to implement a use case. So there's at the right bottom, there's a discount code for Amazon for 20%. So that's 20 Oracle and then WRLD, and that will be active till around 28th of October. But in the future there will be some more promotion for this. Okay, so let's start, right? First, I'm going to look at the public versus permissioned blockchains and what's the difference in that. Then I will look at Ethereum as a blockchain app platform. Tell you a little bit about decentralized applications, what it is, and then look at how you develop those decentralized applications for Ethereum. I'm going to introduce you to a Truffle Suite and the Truffle Boxes. To really is a framework to easily get started with decentralized applications for Ethereum. And then I will introduce the Truffle Box for Oracle Jet that I made. And still a work in progress. So let's look at the public versus permission blockchains, right? So there's a lot of there's a lot of platforms to run decentralized applications right now. There are some proprietary blockchains like Bitcoin or altcoins like Litecoin. But of course, we look at Ethereum for the decentralized applications, and they also have a cryptocurrency, crypto tokens to run that you can use to create your own currency tokens. There are some others like Neo, IPFS, and Blockstack that do decentralized applications, and IPFS does decentralized file systems and stuff. And then in the permission blockchains, we see Hyperledger Fabric is a big permission blockchain from the Linux Foundation, and besides that, there's also some companies like Ares. They have a platform like Monex. They do turnkey blockchain solutions. But in this case, we're going to look at Ethereum for the decentralized applications. The difference, right? If we look at a public permission, is that anyone in the world can read the information and transactions. What's there? It's public, right? They can also send transactions. They can just create an account and join the network, and they can see transactions. They are included if those transactions are valid and written to the blockchain. Anybody can also choose to participate in the consensus process, and usually public blockchains, like the bigger ones like Ethereum, they say fully decentralized. At the other side, we have private and permissioned blockchains, and there's where you would have write permissions, right? And they are maybe kept centralized to one organization or to a consortium that decides right, where to have access to. Even it goes for the read permissions, who can execute which transactions and which functions on the smart contract, for example. And then with the consensus, usually it's a consortium of selected nodes that participate in the consensus. And not everybody, you need to be a little bit authorized. And so you can say that's partially decentralized, because if you're running it on one and the same cloud or a location or stuff like that, then it's still not really decentralized. Okay, so let's look at Ethereum as an app platform. Right, Ethereum, it's a decentralized blockchain platform. So you can find everything about it on ethereum.org. The mainnet, what they have, that's public, right? It runs on a shared global infrastructure with all the nodes. And then, the other thing is that organizations can start their own network, or their own private network, or set up a test network. And of course, here the key features are the smart contracts and the digital currency that can run in it. So what you see with the purposes is that with a public blockchain, you see all the ICOs that are more like companies that seek funding. You have the Ethereum name service. Usually with a public blockchain, you have addresses, and they are really hard to maybe share. So they made a name service to say this name belongs to this address. But also voting and just the funding and advertising network and even games can run on it. So what's a decentralized blockchain application, right? So a decentralized blockchain application is a blockchain application web app, and that runs on the peer-to-peer network of computers, right? Rather than a single server. Smart contracts are allowing you to connect to the blockchain data and the ledger, write and read stuff, and it contains both the front end and the back end. If you look at it as a more pure way, right? And then those front end and back end run independently on all the nodes. Okay, so the back end of the decentralized application is powered by a smart contract, right? Smart contracts are agreements between parties that can be executed automatically or can be called via an API, and they can act as a complement or even a replacement for legal contracts and business transactions. What it actually is, right, is computer code, right? That's why it's a developer session. So it's a computer code that is capable of facilitating and also executing. If you have a paper contract, also to enforce those rules that are written there. So this is an example of a contract that where you can capture your claims. And normally with Ethereum, everything is an address, and you know maybe the address of your friend, and you know that it's from his, but normally you wouldn't know that. This is, for example, a contract that you can say, okay, this email address or this phone number or even or whatever belongs to this address, right? But it's just a simple contract just to show you that it's right. It's just program code. This is a language called Solidity. This is currently the main way to write them. There are some other languages that will, let's say, compile the code so it can run on Ethereum. But Solidity is still one of the main used one, and it's a combination of I think it is C++ or C# and JavaScript and Java. It's a combination of that, but you just see it as its own language, right? Yeah. Okay. So besides that, a decentralized application also contains a data model, right? In the smart contract, you're usually you define what your data model is. Maybe it defines who are your participants. Maybe you have role-based authentication. It also defines what kind of assets you have, right? A contract can control multiple assets, right? With Bitcoin and also other and cryptocurrencies, that is just one usage. And also one asset within something. If you look at more like business or enterprise applications, then you will have just your asset, like maybe a loan object or even an address or a vehicle or whatever. That are assets that can be assets within one contract. Besides that, it depends on what you want to do, but you know, if it's a public blockchain, you can still do authorization and permission models. So, for example, you can build in your contract that you, let's say these kind of addresses that I have, I want to give them the right to vote on something, right? So it's still public blockchain, but you can give certain addresses, so certain people access to a smart contract and execute it. And if they don't belong, if they don't have the rights to do something, then they will get an error back and the transaction will be reverted. Then besides that, you have APIs to connect with the front, so to connect the front end with the back end, so with the smart contract. And the front end can be a web application, or you can make a Java application or whatever that can talk about those APIs. We'll get that in a moment. They can run outside the blockchain, but there are also blockchains like platforms like Blockstack or that you can combine certain things that where the web application maybe also runs on the blockchain and will be distributed between all the organizations, right? But in most cases, what we now see is that it still runs outside of the blockchain. Okay. So how we do DApp development on Ethereum, right? We have, of course, the smart contracts, right? And they can be written in what I said, both Solidity, so it's influenced by C++, Python, and JavaScript, so it was a little bit off there. That's the main one that's now being used. And then there's another language you can use that's called Viper, and that's really influenced by Python. But what in the end both, they will be compiled to bytecode that can run on the EVM, that stands for the Ethereum Virtual Machine. And the code that you, let's say, deploy on Ethereum is available as an address on the blockchain, right? So you can, for that reason, deploy multiple versions of the same contract, because if you deploy it again, it will get a different address on the Ethereum blockchain. So you can, let's say, I will call the old contract for some organizations, and other organizations maybe can use the new one, right? It's just like versioning, what we have with APIs or even database packages and stuff like that. So the interface to the back end, right? If you have a smart contract deployed on Ethereum, you can use Web3, the Web3 interface, and you have that one for JavaScript and also for Java. And if you want to use Go, then in the past we had there was a Web3 one for Go, and then this is just a new version they created, and it's just called Go Ethereum. So there's no relationship with the name Web3 anymore. And then, of course, we have a front-end application that implements that interface, right? Or a Java application or Java FX application that interacts with those with the library of even Android. Okay. So this is an example. I hope you can see it there, but this is an example of what I made for a voting ballot for, let's say, conferences or user groups or whatever to vote on the names. So in this case, if you can see it, and maybe I can, yeah. Okay, what you see here is that you have a struct, and a struct is just like your data object, right? What I said, you need to have a data model. So here we have a voter, and you can have, a voter can have one vote or more votes that you can maybe say, I delegated something. And you know if he has voted and on which proposal that address, so maybe that person or that system has voted. Then of course we have proposals with a name and account, and also the one that initiates the contract. Here's the chairperson that decides eventually on the winning name. There's also one person that can add the proposals, so the chairperson will add the proposals. And then we have a list of voters. So the voter struct will define what the participants look like, but we have a list here of public voters that's just an array of the addresses linked to the voter structure. Okay. Of course, I need to go back like this. Okay. So this is continuing of the contract. So here you see that we this is the old way still. This is before the there's a lot of versions of Solidity, and they made a change in how to, let's say, call contracts from 0.4.22, and in 21 it was like this, right? We have a function called ballot, and that's the constructor of the smart contract, where when we create an instance of the contract, we give a list of proposals names to that, right? And then it loops to the list, and it adds all those those proposal names to a list of proposals, and then sets the vote count on 0, right? Because we just initialized it. Secondly, we have a function give right to votes, and that is that what I said with the permissions, right? You can make permissions, let's say, right? If only the chairman can give somebody the rights, and then the voter, right? They don't need to have voted yet, so it also checks in the list of voters if that address was not already part of that list, right? And if it didn't vote already, and then if it's not like that, then it gets one vote. It gets one vote to use, right? So in this version, I removed the delegates because that was just a little bit maybe too much for now. And then we have a function called vote, where you can really vote for the proposals, right? The structs that you saw, they are public, and that's why if you have with the interface, you can also just directly ask the content of those structures. So you don't have to create, let's say, get functions to get some data. But if you don't want to get the whole structure, but only the winner name, or you want to do computations, then you can do that, right? So in this case, there's a vote, and I also got functions to get separate information as the winner and stuff like that. This example is, by the way, just a normal Solidity example. So if you go to the documentation from Solidity, you will find this example. But I have changed some things, and in the near future, I will change some other things because I'm going to continue creating this. Okay. So there are two things you need to know with the interface, right? So now we have our smart contract done, and we want to go to our interface, right? And then we can do that with the Web3 API. And you have two things. You have a call function, and the call function is executed locally on your own node that you run. And with this, you can read information. And in this case, because we're using the JavaScript function, it returns a promise. This means that it's not a synchronous call, right? You get maybe in a certain time you get the data back, wait your request. So in your applications, you need to really need to know that you're getting a promise back, and then need to update your UI, right? You need to update your UI components. Yeah, so like we can maybe say refresh votes to get a list of all the votes or stuff like that. And then on the other side, you have transactions. And transactions are executed on the Ethereum virtual machine in a network. And with a transaction, you can change the state of assets. It also returns a promise, but it only returns the transaction ID. So if you want to know if something was completed and successful, you need to ask for, okay, this is the transaction ID and what's the status of the transaction ID, right? So there's a little bit of, at the right side, there's a little bit of JavaScript code where you can see that it, for example, checks if the contract is deployed and then do I have an instance, and then it will send the transaction. Okay. So the thing that if you really want to build applications with Ethereum, right? There's a suite that calls the Truffle suite, and it also has Truffle Boxes, right? And let's get into that, because that's the interesting thing. If you want to start now and have your first application within, say, 5 minutes, you can use this. So it's a tool set for developing smart contracts specifically to run on Ethereum. So it contains of 3 things, and the first thing that it contains of is Truffle itself. Truffle is a development environment, so you can develop your smart contracts, but also test your contracts. They have a testing framework around it, and you can make migration pipelines. So if you have a new version of a smart contract, then Truffle will do the migration for you. If you say this is a new version, you do a new Truffle, you compile and migration, then it deploys it to the network you set up, and it does everything around it, right? The second component is Ganache, and Ganache is a personal blockchain for Ethereum development. It comes in two forms, in command line form and also in a UI, where you can see all the addresses and all those things that are there. But we'll go there in a moment. But you can deploy contracts, develop apps, and run tests also here. So then the last one is Drizzle. I won't focus on that one because Drizzle is some nice UI components for React. So if you use React, you can use Drizzle because they have a lot of front-end libraries. To handle the synchronization of data, transaction, and stuff like that. So it brings a lot of to the table. But as I'm using Oracle Jet, I can't use those UI components out of the box, right? Then you need to do also, So I'm going to look at those two, Truffle and Ganache. So Truffle, right? You can do the compilation of smart contracts, even linking multiple smart contracts to each other, the deployment, and even creating binaries that you deploy and even need to use when you create your UI. You can make automated testing. It's really scriptable. It does all the network management, the connection to even your development and production, because you can set up multiple pipelines. And if you say Truffle migrate development or whatever, then it goes to development, but else it can also go to a live environment. Then it also has a console where you can see the communication between the smart contract and going to to Ganache or to other Ethereum RPC environment, but you don't need to use Ganache. You can also use Truffle alone. Okay, so the other thing is Ganache, right? There's one-click personal Ethereum, desktop and CLI. So with this, for instance, in the desktop, you can see the status of all accounts, private keys, transaction balances, and also see log output of the internal blockchain, including the responses and other vital stuff. You can also configure the mining, so the block times of your Ethereum network. And then you can, of course, look at the transactions. You see them on the right and see what happens and stuff like that. Right. So besides the Truffle framework I explained, you also got Truffle Boxes. And so if you're already doing, you want to do building your application with React or with Angular or with Vue or whatever, you can find the box here, follow the instructions, and then you have a boilerplate where you can start. It is all configured. The only thing you have to do is build your UI application, right? But it can be written in TypeScript. Some use Webpack, right? There's a lot of things out there where you can choose what to use. And what I decided to do for this session is I'm making a Truffle Box for Oracle Jet, right? If it works, or if I came to that result, we see that. I will talk that in a moment. But let's go over what it is, right? So I created a Truffle Box for Oracle Jet. So it uses Truffle and Ganache, and I try to I can take some Drizzle components that are built in React and maybe port them to Jet. But it's based on the boilerplate example of Oracle Jet 6 that was released last week. And if you don't know Oracle Jet, it's a JavaScript development toolkit by Oracle, right? It uses open source libraries and technologies, right? It's not a framework like Angular or React or something like that, right? It's a combination of JavaScript libraries and their Alta UI and stuff like that in a way that you can rapidly develop JavaScript applications. So in the latest version, it includes Webpack, web components, and a lot of accessibility support and multi-language tools. But also full life cycle of really rapid for template-based web applications, two-way binding, routing systems and stuff like that. This comes out of the box, and also the UI components. So the Truffle Box incorporates a simple ballot contract, right? The one that Ethereum has in its documentation at first, and I'm doing this presentation in the future, and then it will be more and more and more with more and more functions there, and even supporting events and all the things that Ethereum will support. So the box is available from my GitHub. It's there, and also if you do the commands, it will go to a GitHub to download that. So how to install it, right? This goes for most of those boxes. Is that first you install using npm, you install the node applications like Truffle. We have a dependency on the Oracle Jet's command line tool because we want to build and serve the Oracle Jet application, and we of course use Ganache CLI, so we need to install that. Second thing is that what I want to do, and it's not there yet, is I'm gonna use for the TypeScript with it. Currently, it only communicates with the blockchain to get the proposals and the connection stuff. But for the more like the graphical stuff and the voting and what it's gonna use TypeScript in combination with web components, so it's easier for me to supply updates to it. So that's gonna be installed, and then this is the important command. So if you install Truffle, then you can do Truffle onbox, and then same as the GitHub without github.com. So this is my GitHub account name /Oracle Jet -Truffle -box. Then it will download the stuff, and then after that, there's a lot of information on Oracle Truffle Box in the README file, how to continue and test and stuff like that. Okay, let's start, right? So I've got 50 minutes, right? So let's try what I can show you, right? So I switched to my virtual machine, and I need to do that for you guys also. So let's duplicate my screen. I need to. It's always fun stuff, right? Okay. Yeah. So I'm using, if you don't recognize this, I'm using Visual Studio Code from Microsoft. They have a lot of extensions also for the Hyperledger Fabric stuff that Oracle Blockchain Cloud Service uses, and Ethereum Solidity also has an extension for this. So this is for example, the things that you can do, right? So the first thing what this script does, it starts the private blockchain. So I already did download it, right? I already unpack it, and if you unpack it, you will get everything that you see, the most that you see here, including the CI scripts, right? I add them. Normally, a lot of boxes don't have them, but I followed a color of someone I know from the NL Jerk that also recommended doing, just having this in for you guys. It starts with what you see there in first is 12 words, and I use constantly the same 12 words because then I know that I'm getting the same Ethereum addresses to communicate with, right? So if you're building tests and stuff like that, you know that that address exists. If you don't do that without the name and you start just Kanash CLI, every time you get different addresses, right? So it's hard to write unit tests on that. Then Truffle Compile will compile the code and the smart contracts, and then migration will deploy it to the environment and stuff like that. And then with Truffle Test, you can test your Solidity code if you build a test file, right? So this is the current contract what I'm using. So right, you see the same thing what I showed in the presentation, right? We have a voter. We have the proposals, we have the chairman, the list of proposals, the constructor, and this is the new way of writing it. So in the presentation you saw it said function ballot and then the inputs, and since Solidity 0422, this is the preferred way. The other ways, the other method is deprecated, so this is the way to create constructors, right? You don't have to say function ballot anymore. The contract is also already called ballot, so and in this case you only have one constructor, right, per smart contract. That's the limitation. Okay, so this does the same. I've got the give right to vote function in it, and then also the vote, and also the winning proposal, and even things like get proposals, because I want to have a list of only the proposals to show you in the so I don't know currently have the votes in it. I want to start simple for myself. There are some things here like so the contracts. There's also a migration contract that's part of Truffle that handles a lot for you. Then you have migration scripts that say, oh, deploy this, and here you can also link contracts to each other, but if you're interested in that, you can look at that. And then I've got a deployment scripts for my contract. So in this case, I want to do this new. So what should I add to this list? Something weird, right? You decide. No, nobody? Something weird? Duke, okay. Let's do that. Duke. Should I put it somewhere not at the end, right? Let's put it at second, right? Then it's not like, oh, it's already there. Okay, so put it in the center, right? So what this migration script does is it deploys the contract, and then with the ballot name, and it gives the list of proposals because the constructor requested that, right? The other things what we have are the sources from the JET application, and also the tests. So I made a test ballot, and that test ballot does also some counts. It does getting the proposals, counting the proposals. You can write those tests, right? Even if you're not doing the UI stuff or whatever, you can even create the tests here. That's part of Truffle. And Truffle uses their own fork of Mocha, and Mocha is a test framework also in Java, but they use the same. But then for this, yeah, and some other tests, right? So it does that, and then so let's get it going, right? And then also I've got the most important stuff here in Jet for you to know is that Jet uses a knockout and other ways for two-way binding, but also you see here the way that they are, let's say, including libraries, right? So the Web3 is part of, because you can install it with npm, just like the other modules, and then the important stuff here is that I'm using MetaMask. That's a browser plugin, and if you use MetaMask, then it will inject a lot of providers like this. And when you and if you don't have it injected automatically, you can also just use the URL where Ganache is running on, or your other Ethereum blockchain. And then what you see here is that it does a ballot contract with using the newly created Web3 instance to create a new contract. And what it uses, it needs an ABI, and that's an application kind of binary. And that is, if you do a compile on it, then it will generate that file. So in the build, it will generate a JSON file, and that's the ABI, that's the connection stuff. So it's there, and then I will change the UI. So let's run this, right? Let's say CI build. So it will start up at the bottom. You will see that it will start up the Gnash CLI. It compiles the ballot and the migration. So it going to do the code, then it does so compile, then it truffle migrate. So it's now deploying, right? I know here you can see also the address of the ballot, right? This one. Oh, we need to have that in a moment. Please, 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 please give it. Yeah. Okay. Ooh, that was wrong. No. Sorry, guys. Another time. I think the address maybe changes when I started, so that's why I just copying it for certainty. Ballots. I think it's the same. Okay. So now it does the Truffle tests. It compiles everything again because Truffle is a test is a different session, and it uses a different solidity file, right? So it in my test there's 3 things. They all pass, and then it does an OJet build. So it's now building my Jet application. And then it's going to do an OJet serve, and it serves me the web application, right? So now it's going to also go to the browser, right? It's an empty list, and now it connects to a MetaMask. And I think, because I'm not logged in yet, I need to figure out something on that, because I'm not logged in yet. Yeah, it changes. It changed, guys. How long do I get? 5 minutes. Yeah, let's do this. Settings. Nope. Extensions. This is the problem with the MetaMask, is if it doesn't find the correct, if it changes words and accounts and stuff, then it's not there anymore. So more tools, extensions. Let's remove MetaMask for a moment, and then quit the browser. Start the browser and start it over again. MetaMask. So MetaMask is what I said is the browser plugin that you can use to easily set up your digital wallets. So let's add Chrome, add the extension, right? Then go to MetaMask here. And I will say, yeah, okay, go to the beta version, continue. Then what you do here, if you are new, and that's interesting that this happened, because then I can show you, but you can import the seed phrase. And the seed phrase is the one that is used by Kanash to start it. And I need to go to my build files. And it uses this line of words. And then what I can do here is put it in, just give a simple password, doesn't care. And then I can import it. And now with the phrase, I get all the accounts that are there. If I accept everything, okay, it's there, right? And then I can connect to my local host. So that's the local private network. So I can immediately see that I've got around 100 Ethereum here. And I can even import different accounts and stuff like that. But let's start with just one for now. So now it's running again, and I will go to my decentralized application. Right, and you see here, right, this is the list of what I inserted for when I deployed the contract, right? So this is not a pretty Oracle Jet application yet. I'm working on it. So what I want to do is also insert events and all the other stuff and making lists and doing the forms and stuff like that. So in the future, I will really creating a decentralized application further with this. You can already start with this Truffle Box and download it and see what happens and play with it around it. And then I think in the next month, this will get updates, and it will get TypeScript, and it's going to use Webpack, and it's going to use customized web components and stuff like that. So you really can use it in a proper project. So yeah, I think this will end my presentation today. So yeah, thanks for coming, and for the guys that are interested in blockchain and stuff like that with the book, come walk around. I've got a nice card with a discount code for Amazon. So yeah, thanks for coming, and great week.